Joke of the day, did you get it?
Wait, where are my notes? Oh,
F.
Deriv of a cow is a line.
Oh.
Okay. Okay, so today we're gonna learn what's called the first step. The first derivative test. This is not, I don't think it's as difficult as what we've been doing, hopefully. But it does involve you writing correct statements. So the first derivative test tells us the following information about the original function. It tells us what's happening at critical values. And as a reminder, how do we find critical values? F prime equals 0 or F prime is undefined. That's how we find critical values. The first derivative also tells us intervals of increasing and decreasing. If F prime is positive, that means the original function is increasing. Remember, if the derivative is a slope, if you have a positive slope, your function's going up. If the function is decreasing, that means the derivative is negative. I forgot the derivative. So if your derivative's positive, the function's increasing. The derivative is negative, you're decreasing.
How do we know if it's positive or negative?
We're gonna find out either given an equation or given a graph. All right, so it will also tell us minimum and maximum values. So if you have a function that increases to decreases, that's going to be a maximum. If you go from decreasing to increasing, it's a minimum. So what would be happening on the derivative? The derivative would be positive and the derivative would be negative. All right, these are also minimum and maximums, could be horizontal tangents, which is where the derivative is 0. How we do the first derivative test is we list our critical values on a number line. The number line must have the correct notation, which I will model, and intervals for increasing and decreasing need a statement. College Board will not accept a number line as a justification. They need you to write out the statement. And you need to make sure you understand what's happening at all critical points. All right, so let's start with an example. Now, okay, so first step is to find critical values. So critical values are found by finding the derivative equaling 0 and the derivative undefined. So what does that mean we have to find? The derivative. So the derivative of f is 6x plus 8. So I'm going to take 6x plus 8, make it equal to 0, and I get -4/3. Where is the derivative undefined? Nowhere. The derivative is a line, it's always defined. All right, so next, our next step after we find our critical values is to put them on a number line. So my number line, I'm going to label with F prime. Because this is the first derivative test, and we want to know what the derivative tells us about F. I'm going to put my critical value on the number line. And above it, I'm going to put why was it a critical value? It was a critical value because the derivative was 0. So I'm going to put a little 0 above it. Now we're going to do test values like you would normally do on that number line. So if I plug in a number less than -4/3, like -5, where am I plugging -5 into? No, F prime. That's why we label it. It's a reminder of where you're plugging the numbers into. So when I take -5 and plug it into the derivative, I am going to get a negative number. If I go to the right of it, let's plug in 0. If I plug in 0 into the derivative, I get a positive. So what is this telling us? So now I like to say underneath, what is it telling us about our original function f?
Increasing.
So if the derivative is negative, the f is decreasing. If your first derivative is negative, it means the original function is decreasing. If your first derivative is positive, it means the original function is increasing. Now, I'm more visual, so I kind of like to say, okay, decreasing, increasing. So what is happening there? A minimum. Okay, can I find f of -4/3? Can I plug -4/3 in there? Yes, I get a number. I just don't want to do all that math right now. Okay, so now we have our picture, and from our picture, we can write our statements. So you're going to write a statement for intervals of increasing, decreasing, and critical values. So we're going to say f of x is decreasing on what intervals? -infinity to -4/3. Note, don't ever use the word it. In calculus, it could be f, f prime, f double prime. So you need to name the function. So f is decreasing on this interval since or because f prime is what? Negative. So you can either put negative or you can write it as f prime less than 0. Both of those are correct. Then we have a statement for increasing. So f of x is increasing on the interval from -4/3 to infinity, since f prime is positive, or you can say f prime is greater than 0. And then the last statement is that f of x has a minimum at x equals -4/3, since f prime changes from negative to positive. If f prime changed from positive to negative, it would create a maximum. Okay, so you do have to be specific there. Okay, now calculus was invented a long time ago, right? So it was before graphing calculators, before any of that technology. So they used calculus to learn how to graph any graph. So you already knew, if you think about this, this is a quadratic that opens up. So you knew that it would decrease, then increase, and it had a minimum. Okay, this is also where I like to show you, what did we just find at -4/3? The minimum, which is the vertex, right? You have been finding the vertex for years. You've been doing calculus for years. You just didn't know it. So I like to bring this up now. So we have a quadratic function. F of x is equal to ax squared plus bx. This is just a side note. You don't have to write it down. Here's the quadratic function. What did we do to get that -4/3? Derivative equal to 0, right? In math 2 and math 3, how did you guys find vertex? X equals -b/2a, right? You just thought that formula fell from the sky. Well, if I take the derivative and set it equal to 0, let's see what happens. 2ax plus b equal to 0. You have been doing calculus all along. You just didn't know it.
What?
So that's where it comes from, is it's taking the derivative of a quadratic function and setting it equal to zero. That's your horizontal tangent. No. A is a constant. No, I like to throw that in there. Okay, all right, next we got one, I'm gonna have 1 minute to find the derivative. Come on, man. Quotient rule, find the derivative. Who thinks they got it?
And I put this. And then something to go on.
Oh, oh. All right, what'd you get?
Negative 18x over.
Negative 18x over x minus 9.
Oh, yes.
Squared? Low. Yep, very good. We got the derivative?
Yes, ma'am.
Okay, what do we do next? Critical values. So critical values are where my derivative is equal to zero and where my derivative is undefined. Now, when you have a fraction, basically the derivative being zero is setting the numerator equal to zero, because if you have a fraction and it equals zero, that means the top has to be zero.
Yeah.
A derivative being undefined, if you have a fraction, would be the denominator equal to zero. So that's how you find like where the derivative's zero and undefined. So we're gonna set the top equal to zero and we get zero. We're gonna set the bottom equal to zero.
Plus or minus 3.
Right, now I'm gonna check here and I want to know, what is f of 3?
Undefined.
Undefined. You would get 9 over 0, right? That's undefined. What about f of negative 3? Also undefined. What about f of 0? 0. Okay, so 3 and negative 3, there's no part on my graph. What is happening on my graph at negative 3 and greater? Vertical asymptotes. All right, the next step is we make our number line. F prime. All of our critical values go on our number line. Now, where am I plugging into? F prime. So when I look at F prime, the bottom is being squared. So that means the denominator is always going to be positive. So when I'm plugging in test values, I only really need to plug it into the numerator. So if I pick like -5, it's going to give me positive. If I pick negative, yeah. It's going to give me another positive. If I pick 1, negative. If I pick 5, negative. Okay, so what is happening on F? Oh, I forgot -3, I found because the derivative is what? Undefined, so I'm gonna put a little u. And I'm gonna put a little u by 3. At 0, the derivative is 0.
Put a zero. above it.
Put a 0 above it.
You gotta go.
-1 and 2 for the
Okay, so what is happening on f?
for sure.
If f prime is positive, f is increasing. F prime is positive, f is increasing. F prime negative, f is decreasing. F prime negative, f is decreasing. Now, we already talked about on f, -3 is undefined. So it's also undefined, and we said that there was a vertical asymptote there. Same thing with 3, there's a vertical asymptote. What about 0? If I'm increasing to decreasing, that's going to be a maximum. I ran out of space there. Okay, so now when you write your statements, you're going to say f is increasing since f prime is positive. Okay, so that's how the number line helps you with your statements. So we have a lot of statements today.
Fine.
F of x is increasing on what interval?
Wait, f of x or f nothing?
F of x. We're learning about f based off of f prime.
Oh,
So -infinity to -3 and 3 to 0. Since f prime is positive, I'm just going to put greater than 0 this time.
wouldn't it be -3?
Yeah, thank you. Well, good. -3 to 0.
Plus or zero.
Our next statement is for decreasing. F of x is decreasing on the intervals from 0 to 3 and 3 to infinity. Since f prime is negative. Remember, you are being graded and scored on your knowledge of calculus. So you have to relate everything to a derivative, and that's your knowledge. Like that's showing your calculus knowledge. Like you knew a quadratic, you know how to find a derivative or the vertex, but they want to know, do you know how to find it using calculus? Now at 0, so we're going to say f of x has what? A maximum. And we actually found the y coordinate, right? We plugged in 0 into the original. So you could find the actual coordinates of it. So it has a maximum at x equals 0, since f prime goes from positive to negative. And then we're just gonna, just so we know what's happening at all critical values, f of x has vertical asymptotes at x equals ±3. And that's because f and f prime are undefined. Yes. Yes, so that's what, when you have the derivative being undefined, 3 things can happen. It could be an asymptote or a discontinuity. It could be a sharp turn, or it could be a vertical tangent. And we're going to talk about that a little bit later. Yep. Okay, so as far as abbreviations, they tell us for when you take the actual AP exam, they don't want you abbreviating anything because different teachers use different abbreviations and we don't know who's grading your exam. Now, I'm grading your test. We're all using the same abbreviations. So for my test, it's okay if you abbreviate. Yep.
Sorry, can you circle back to the underline?
Yep. Yep. Okay, so I took like -5 and I'm plugging it into, where's my derivative? I'm plugging it in here. So when I plug in -5, it's gonna be a negative times a negative, which gives me a positive. But this is squared, so it's always positive. So a positive divided by a positive gives me that positive. If I pick 1, -18 times 1 is negative over a positive, which would be negative. Okay? All right, go ahead and see if you can do the next example, the whole thing on your own. What do we need? 3 minutes? No? You longer than that? Make sure you got your derivative right. Will the derivative equal 0?
No. Nope.
Why? Make
The
them
numerator.
fractions.
Because 2 does not equal 0. You cannot equal
But
0.
our numerator.
Again. So is there no critical?
There is a critical number, but
It's when it's undefined.
it's when the derivative is undefined.
Oh, so the denominator.
You don't have to.
I knew that just for sure.
It does not. It has a design.
X is 0 and denominator.
The negative numerator equals 0.
That's why I plugged it into the original events. Right?
Got X equals 0.
Scott,
Uh-huh.
or like the previous problem, in the last line, you said that f has be x equals plus or minus 3, because f and f prime are undefined. In this function, f is
Q, then it's still gonna stay nice.
but f
If it's
is
squared, then it's
it's a bad.
So, shouldn't be because
No, it's negative. It's so nice.
Oh, yeah.
the math is, but if it's derivative, it's only some kind of negative.
Yeah.
So Wait, this. No. It's a huge garden. That's where. That's not very. Let's go, you put the numbers into the, like, the number line, whatever.
Yeah.
Use a prime or.
F prime.
I don't like. Okay, Christian, what if you're liking?
I think you're to a point where you're trying to figure out what is happening at 0.
Yeah.
All right, so let me just catch up. So I found my critical value only to be at 0. And remember, I plug into f prime, so f prime has a cube root. So when I plug in a negative number, the cube root is negative. When I plug in a positive number, I'm gonna get a positive. I got 0 because the derivative is undefined. So now I'm gonna go up and let's see what's happening on f. So what is f of 0?
0.
0. So there's a point on f. So we have to figure out what is happening. So on f, my function's decreasing, then increasing. So decreasing, increasing, which means this is a minimum. And what type of minimum, if the derivative is undefined, we can have a vertical tangent, which looks like that, kind of like your cube root function, or we could have a sharp turn, or we can have a discontinuity. But the original function has a point on it. So it's a sharp turn. And if you look at the graph, I were to pull up Desmos, the graph of this looks like that. So your original function is decreasing and then increasing, but at zero, it's creating a sharp turn. Yep.
Is it because it's the cube root of x squared, so it'll always be the cube root of something positive? Is that why it's like that? For f of x. And you're taking the cube root of x squared, and anything squared.
Yes, and so like
It'll always stay
it
above.
like
makes sense.
reflects up. So like if you take the cube root, that other thing gets reflected up to create a sharp turn. Yep.
Wait,
All right,
how
so
would you
now
write
our-
this statement?
Our statements. Here are the statements. So we're gonna say f of x is decreasing on the interval from negative infinity to zero. Since f prime is negative, f of x is increasing on the interval from 0 to infinity. Since f prime is positive, and f of x has and I'm gonna include this just so you have it in your notes. I'm gonna say a sharp turn minimum at x equals 0. Since f prime changes from negative
Oh, I was.
to positive, and well, you could say f prime is undefined and f changes from
Say
negative.
f prime 0 is on.
Yes, yep, yes.
How do we know that it's not, a vertical tangent?
A vertical tangent, okay, so a vertical tangent, what happens is your function's increasing and continues to increase. So if this was positive and positive, it would be a vertical tangent. But the original function has to be defined.
How do we know that it's like continuous?
You'd have to know something about the original function. So we plugged into the original function, and because we got an ordered pair, that function was defined.
The graph is continuous.
Yeah. All right, go ahead and try the next one. Find the derivative, at least.
Is this one where we have to do quotient?
Quotient rule.
I don't want to.
Can you
Just bring the x to the top.
So that for the negative one.
This, well, actually, it's not, it's particle event, it's event, like, pick your voice. I don't want
my
my
explanation.
It's like, it's a product or course, you gotta do one of those, like, pick your voice. Which one you want?
I want lemonade.
I'm looking favorite potion. I don't want.
Where do you take that? Okay,
I'm thinking.
you could say it starts minimum. And that every time.
I did that.
Oh,
Wait, what you I did too.
Actually, yeah, the X one, yeah, the X one.
Wait, would there be a,
Anything can't equal 0, right?
would there be a value where it equals 0 on this one?
Yeah,
there
that,
is.
that D.
Okay. So if
You stuck on trying to find where the function equals 0?
actually,
Factor out e to the x.
that's what I did.
What's the score?
Wait. No, I have to plug it on the side. You're gonna have to plug in like a fraction.
Plug in, I ain't kidding you, that's when it's.
Calculator.
Okay, so when you get here, will e to the x ever equal 0? No. So you should have two critical values, one at 1 and one at 0. Yes.
I just added the other side and divided by it.
Okay.
Is that wrong?
It's not wrong, but if it was something other than e to the x, it might not work because the reason why it's okay is because e to the x can never be 0. Yeah. All right, so my number line, I'm gonna do it over here. All right, when we plug in, I'm gonna plug in as, I'm gonna factor out that e to the x. Okay, x squared is always positive. E to the x is always positive. So when you're plugging in, all you have to plug in for is in here. Because this is gonna be positive and this is gonna be positive. So if I plug in -2, that's gonna give me a negative. If I plug in 1/2, it's gonna give me a negative. If I plug in 3, it's gonna give me a positive. This happened because f prime was undefined, and this happened because f prime is 0. So now, can we find f of 0? Undefined. So what's happening at 0? Vertical asymptote. Can I find f of 1? I get e, so there's a point there. All right, so f is decreasing, decreasing, increasing. Here, I'm decreasing, oh, we already said vertical asymptote, right? Yeah, vertical asymptote. And then I'm decreasing, did I do that right? Yeah, decreasing to increasing, which is a minimum. All right, so f of x is decreasing on -infinity to 0, 0 to 1. Since f prime is negative. F of x is increasing on 1 to infinity. Since f prime is positive. F of x has a minimum at, I'm going to put the coordinates this time, 1 comma e, just so that you know you could put the coordinates. Since f prime negative to positive, and f of x has vertical asymptote at x equals 0.
Yes, question.
Since f and f prime are undefined. All right, we're good. We're getting there. Yeah. Because when I went and took 0 and tried to plug it into the original, I got 1/0, which is undivided. Your previous knowledge of rational expression, vertical asymptotes are where the denominator equals 0. All right, so critical point. If the derivative is equal to 0, 3 things can happen. You can have a minimum, you can have a maximum, or you can have a level point. What is a level point? That's when you increase but level out. So you have a horizontal tangent in there, but the whole function's increasing, or the whole function's decreasing. And whoops, not that way. That's a vertical tangent. Whoops. How can I do decreasing?
Level.
Like that, sorry.
Is that?
Like,
Level.
it levels out, kind of like your cubic function.
Yeah.
Okay, if f prime is undefined, we can have a discontinuity. Which is usually a vertical asymptote. That's when f is undefined. Okay, f and f prime. You could have a sharp turn min or max. And you could have a vertical tangent. Sorry, you ran out of space. A vertical tangent is when the graph does that or that. So how do you know when you have what? We have a little reference sheet for you.
Horizontal tangents, not like the correct value.
The horizontal tangent is a critical value. It's where the derivative is 0. Okay, so this little half sheet will help you to determine what it is.
Will there ever be an instance where like we can't use either of the critical points?
What do you mean you can't use?
Like, if neither of the critical points are actually points on the graph.
Oh, if they're both, it could be, I guess, like, you just have two vertical asymptotes.
Yeah.
Don't worry. It's like.
Nah.
Okay, so looking at this, what we have drawn is what the number line of the first derivative test would look like. So if your derivative is 0
That's true.
and on your number line, it's a critical value because it's 0. You get a positive and negative. That's going to create a maximum because f is increasing to decreasing. If you get -0 positive, it's going to be a minimum. If you get +0 positive, the function's increasing the whole time, it creates a level point. -0 negative creates another level point, but the function's decreasing. So we drew little pictures along with the number line so you could relate it. If the derivative is undefined, you first need to determine if it's a vertical asymptote. How do you determine that? You see is f of x defined? So you check to see if there's vertical asymptotes. If you know that it's not a vertical asymptote, then this is what would happen. You have positive does not exist to negative creates a sharp point maximum. Negative does not exist to positive creates a sharp turn minimum. Positive, undefined, positive is a vertical tangent where the function's increasing. And negative, undefined, negative is a vertical tangent, derivatives decreasing. Yes.
And then it's a vertical asymptote if you plug in the point comes out.
If the original function's undefined. You'd have to be told something about the original function.
It's like.
Then it would be one of these things. Yep.
So for it to be vertical, it's to like they put that.
Yes, both f and f prime have to be undefined for it to be a vertical.
If you plug in the value.
Or that's after.
Yes. Yep.
Okay.
Okay, last thing is sketching. This is, we take baby steps. And so you really have to focus on the little steps because eventually we put it all together and it gets difficult. Things to remember. The Y value on the derivative represents the slope of that point on the original. So if I have a horizontal tangent, that slope is 0. So that would turn into an x-intercept on the derivative. If I look at a graph and the tangent line has a slope of 1, that y value would be 1 on the derivative. If your function is increasing, that means the derivative is positive, which means the graph of the derivative would be above the x-axis. If your original function is decreasing, the original or the derivative is negative, which means the derivative graph would be under the x-axis. And then we're going to consider the rate of change of increase and decreasing. Are you getting steep and then less steep, or are you getting less steep to steep? Okay. So we have two graphs, and we are going to sketch the derivative. Or I'm going to sketch it. You're going to kind of follow to see if you understand. So I want to relate it to what we just did, the first derivative test. So if this is f of x, I'm going to make a number line. And I'm going to put my critical values. So critical values are where the derivative is undefined. So look here, there's a derivative. Derivative is 0 or undefined. This function's never undefined. 0, there, and there. So what x values? -1 and 2. And the reason why they are critical values is the derivative is 0. Now, what is happening on this portion of the graph?
Increasing.
It's increasing. So f is increasing, which means f prime is negative. If you're, no, positive, what the heck? F is increasing, f prime is positive. No wonder why you would be funny. Over here, it's also increasing. Sorry, I skipped a segment. That is also increasing. So this portion is also positive. But in between, it's decreasing, so that derivative is negative. Okay. Horizontal tangent, what's my derivative? 0. So I'm going to put an x-intercept here, and I'm going to put an x-intercept there. You told me this was increasing, so that means when I graph the derivative, it has to be above the x-axis. Now, I am going from steep to 0. So that means my y values are going to go from big, whoa. What happens? I'm going to go from big to 0. I'm drawing the derivative. So my derivative, hold on, let's start.
It's a cubic function, so it's going to be 5.
So this function's increasing, which means my derivative has positive values. Positive values are above the x-axis. So I'm going to be up here until I get to 0. In between there and there, my derivative, my function's decreasing, which means my derivative's negative. So I'm below the x-axis. But I'm going from 0 to steep back to 0. So I'm going from 0 to bigger back to 0. No, we're decreasing, so we need to be below the x-axis. Then after this point, that yellow segment's increasing, which is above the x-axis, and it's going from 0 to big. So 0 to big. And that's how we would sketch f prime. No, it doesn't. So the y values, like how low your bump goes, isn't as important as the shape.
It's quadratic.
Yeah, so like if you think about it, like right here, if I drew a tangent line, the slope of that is maybe like -2.
It's just.
So at that point, my y value is about a -2.
It's below because. One and one and two instead of that.
It's decreasing. Yep. Yep. All right, this one. What's happening here to this graph? It's decreasing the entire time. So what does that mean? F prime is the entire time? Negative. So my graph is gonna, my derivative graph is gonna be somewhere down here, below the x-axis. Now, I'm gonna look at my slopes. So if I were to take a tangent and drew a tangent, a tangent, a tangent, a tangent, what's happening to the slopes? Decreasing, they're getting closer to 0. So they're starting as big negatives and then getting smaller negatives. So my graph is gonna go big negatives to small negatives. Let me get rid of that variable. So it's gonna look like that. That is F prime. Now, that stuff, like I said, that's the second half of our chapter. We do, and we kind of take baby steps and it gets more and more complex. So make sure that you're understanding the little pieces until we put them all together.
What do you think so special about that? Like the easy X is just. Why is it that?